Okay, lesson 20. What is today? The 15th? Change of base. So we're talking logs here. So change of base and logs, and then graphing conics using the graphing calculator. So we review back to officially Algebra 2, but you also reviewed it in pre-calc. Change of base formula for logs. Well, shoot, we also did it a few sections back in calc, didn't we? I was like, wait a minute, I haven't reviewed this with pre-calc yet this year, I don't think. So that's right, it was you guys. So y equals, if we have log base b of x, okay, when that log is not a log that a typical calculator does. Okay, now technically if you figure it out, these calculators do any logs, or any base log, if you know where to go to put in. But typical calculator does not, and sometimes it's just solving a problem. We need to use this technique. But log base b of x, you can change it to natural log of x divided by natural log of b, or log of any base x divided by a log of any base b, meaning you could use log base 10. Okay, and those are the ones that we have calculator buttons for. So natural log of x divided by natural log of b, or log base 10 of x divided by log base 10 of b. So example 1. Rewrite log base 4 of x using common logs. So vocabulary, common logs means log base, what's common log? Base 10. If it said natural log, that'd be base e, right? So how can we rewrite log base 4 of x using common logs? It's log of x divided by a log of 4. Now, I wrote base 10 in there just to show, but remember, do we actually have to write base 10 when it's base 10? Right. And so really the best way to write this is log of x divided by log of 4. But because they said to rewrite it using common logs, that's why we use base 10. Okay. Example 2. Officially it says to estimate, so we're going to write around a decimal answer. Estimate log base 4 of 67 by using a calculator. Now, based on the topic today, how do we rewrite this using a different base? Yes. Log of 67 divided by log of 4 is ideally what I'm trying to get you to say. Now, if you know how and you have your fancy calculator with you, yes, you could do log base 4. But you don't necessarily have that, right? Not on the screen, am I? There we go. So if I do log of 67 divided by log of 4, you get that answer? Now, we've been talking about common log. Technically, we could have done this with natural logs also, right? You could do natural log of 67 divided by natural log of 4. Notice my answer is identical, yes. It's probably in the math menu is my guess, and I don't even know that I should show you this, but I know it's up in the alpha menus. Which one? Alpha F2. If you go down to number 5, there's log base, and so you can say log base 4 of 67, same answer, right? So, again, and that's not, I know, the design behind the problem today, but, so this is approximately 3.033. If we go with the AP book, they go 4th decimal place and say 0. AP Calc says 3.033. Okay, example 3. Use a calculator to approximate 4 log base 15 of 6 plus 5 log base 4 of 7. And again, this is not putting it into your calculator and changing the bases on your calculator. How can we use our change of base formula here? Actually, multiplying by 4 would be your better bet. If there is a power, you would have to pull that power out front before you use your change of base formula. So it would be better to just say, okay, we're going to do 4 times log of 6 over log of 15, and then plus 5 times log of 7 over log of 4. And again, I used common log there. You can use common log or you can use natural log. Whichever one makes you happiest. And then it's, can you type this in your calculator and not make any mistakes, right? So if I do 4 times, and if I go ahead and do the fraction, log of 6 over log of 15. I didn't finish my parentheses there, but I think it might have let me be okay. We'll find out. You know what? I'm going to find out. I'm curious now. 5 times, oops, fraction, log of 7 over log of 4. Okay. So because I was, oh, it automatically, I didn't finish the parentheses, but it automatically finished them for me when I hit enter. Interesting. Now, if there had been something right after that log number, obviously I'd have to finish my parenthesis, right? Because they're both at the ends of fractions. So 9.664, 9 tells 4 to go up. So 9.665. 9.6650, either or. You're going to let me know if you have a calculator issue, right? Okay, thoughts on example 4. If log base b of 47 equals 17, what is b? I would do left, right, middle, yep. What does left, right, middle give us? B to the 17th equals 47. How do I find B?
I don't know what you would say.
17th root is what I would say. If it's b to the 17th, we take the 17th root. So we're going to do the 17th root of 47. Can your calculator do that? Yeah. Even your good old-fashioned scientific calculator could do this. You just had to know how, okay? It's up in one of the alpha menus, or you can go into math. Because if you go into math, you can go right down there to number 5, the x root. So I can fill in the 17th root of 47. It's also in, is it alpha F2? Yeah, it's number 6 in alpha F2. 1.254 or 1.2542. Okay, moving on. That was some good old-fashioned log review. Okay, graphing origin-centered conics on a graphing calculator. Okay, so basically, if we want to graph x squared plus y squared equals 4 on our calculator, what has to be true to graph something on our calculator? Has to be y equals, right? So, now, in reality, can you picture x squared plus y squared equals 4? I mean, granted, there's a hint right there, but it's just like an ellipse, except since x squared and y squared are the same coefficients, then it's going to end up being a circle with radius, not 4, but 2. Okay, so this is going to be a circle with radius 2. Now, to get this in on our calculator, we need to take this equation and solve for y. So, y squared is going to be 4 minus x squared, if you will, or negative x squared plus 4. And then what do? Square root it, right? Y squared becomes y. What's the square root of 4 minus x squared? The square root of 4 minus x squared is the square root of 4 minus x squared. You can't take the square root and say 2 minus x because these things are being added and subtracted. Okay? And when we take the square root in an equation setting, plus or minus. How do I graph that on the calculator? Right, yeah. Our calculators, as nice as it would be, they don't let us do a plus or minus. So you're going to, it's like y1, you can say the square root of 4 minus x squared. And y2 could be the negative square root of 4 minus x squared. Or I got another little shortcut for you if you want. But we have to type in y1 regardless. So y1, square root of 4 minus x squared. This trick works. So one option is, yes, you could type in negative square root of 4 minus x squared. And in all honesty, that wasn't that bad, was it? Because it was a pretty easy equation to type. Now, on occasion, you'll have big, long, ugly equations that the only difference, and this works because if the only difference is a negative sign. So if instead we wanted to say y2, it's the negative of what? It's the negative of what's already typed in y1. Well, if you go, I'm sure it's somewhere else, but if you go into your alpha shortcuts, so I think it's probably up in alpha F4. Notice there's a y1, y2, so on and so forth. We want y2 to be the negative of y1. So if I hit enter right there, now it says y2 is the opposite of y1. And that would be equivalent to me typing negative of square root of 4 minus x squared. Okay? So it doesn't matter if you just typed it in, it doesn't matter. Just trying to show you tricks. Okay. So your graph looks similar to my graph. Okay. Now, is this what it's supposed to be? Is this a circle?
Yes, with radius 2.
With radius 2, and you know that because you counted the 2's, right? Well, that's what I'm looking for. You count, okay, you can tell it goes 2 up, 2 down, 2 left, 2 right. Does it look like a circle? Kind of looks like an oval. It kind of looks like an ellipse, yes? Why is that? Yeah. If you look at your screen, are my tick marks equal? Because this screen is technically negative 10 by positive 10 in both directions, right? But notice what's happening. On my x-axis, my screen is longer, isn't it, than it is tall. And so these tick marks are spread out farther. These are squished in closer together. Now, this is just good to know. If you want this to look like a circle, if you go into your zoom menu, you have something called z-square. And what that's going to do is that's going to square your window up so it appears like it should. So each of the tick marks are equal. So if I go down to number 5, can you tell now how my tick marks are equally marked up and down and left and right? So that makes my graph appear more accurate, if you will. I think because they feel like it's easier for you to have equal numbers, that you know your graph goes 10 in each direction. That's my guess. I don't know. I mean, I always teach you guys go to a z standard, which is number 6, because that gives you the 10 in each direction. Could you always go to a z square instead? You could. What does z squared take us to? It takes you, your y mins and max stay at 10, but then your x mins go to 16 point something. Just a little bit past 16. So, you know. So just, you know, helpful information on the calculator. So, yes, I did get a circle with radius 2. My graph did not really appear. One of the tricks we could do is y2 equals negative of y1. And another trick we can use is we can use z square to make it look better. Okay, so some tricks there if you want to make notes to yourself. Do you have to use either of those tricks? No. I just don't want you to get to the end and, wait a minute, this is supposed to be a circle, I got an ellipse, what'd I do wrong? You didn't do anything wrong, it's just how the calculator shows it. Okay, you ready? What are your thoughts on example 5 here? Got to solve for y. What do you want to do to solve for y first? Yeah. And knowing, we just have to be able to enter this on the calculator, right? So it doesn't have to be pretty. We just have to be able to type it in. So if we're trying to get the y term by itself, leave y squared over 9 where it is, and subtract over x squared over 4. So I have y squared over 9 equals 1 minus x squared over 4. Now what? It's y squared divided by 9. We're going to multiply by 9. Y squared over 9 times 9. Y squared. On the right, what do we have to do with that 9? Yeah, we're distributing it. 9 times 1 is 9 minus 9 times x squared over 4. 9x squared over 4. Or you could say 9/4 x squared if you want. Square root. So y is equal to what are you writing? Plus or minus the square root of 9 minus 9/4 x squared. And again, we can't square root that and say like 3 minus 3/2 x because it would have to factor into two matching factors. Okay? Could you use the trick y1 equals negative y2 this time? You can. If you already have it typed in on your calculator, you don't even have to change it. You just have to change y1. So if you want, you could use the fact that I wrote that wrong. y2 is equal to negative y1. Yeesh. So that means for me, like I already had y2 equals negative y1 there, so I don't have to change that. I just have to change what's under my radical here. Square root 9 minus 9 over 4 x squared. Now, I just went back to Zoom 6, which is a standard screen.
I was going to say this one looks like a circle in Zoom 6 than the last one.
Yeah. But how do we know it's not a circle? You can see, right? I mean, you can see that it's an ellipse because, first of all, it goes up and down 3, but only left and right 2. If you guys remember anything about ellipses last year, on the x-axis, we're going to go out square root of 4, right, which is 2. In the y direction, we're going to go out 3 both ways because it's square root of 9. Does that sound familiar? And it always has to equal 1, right, if it's an ellipse. it's adding, which tells me it's an ellipse. If it was subtracting, instead of an ellipse, it'd be a hyperbola. Does it sound a little familiar? Okay.
That was a big part. That was like the whole middle.
I remember like all.
It was like the month of January or so. I don't know. Because technically it's trig, and so that starts our second semester. Okay, now, curiosity then. If you go into z square, it actually makes it look like an ellipse. So this is a place where it is kind of helpful to use the z square because it makes it look like what it is. So multiple different ways to tell it looks like an ellipse. You don't have to rely on the graph to know it's an ellipse. Okay, that's one of those pre-cal trig things that we spent some time, going over them. We didn't really use them a whole lot after that. It's just one of those things where they randomly pop up. So, okay. Questions there? Didn't remember this lesson being quite so short.
Say, what's the catch?
We're done. Tomorrow we get a really long lesson instead.
I guess it's kind of good that I didn't get one because I would have missed the lesson. Maybe go.